Let's take problems to find the principal values of inverse trigonometrical functions. Before that, we will take some properties. If sine inverse x is equal to y, then it can be written as that x equal to sine y. Second is that sine inverse x is not same as of the sine x whole inverse. These two are different. Third is, if we have the function that sine of sine inverse x, then its value will be x. Cos of cos inverse x is also equal to x. And similarly, we can write for the other four inverse trigonometrical functions. Fourth is, if we have the function like sine inverse of sine x, then its value will be x. Cos inverse of cos x, its value also equal to 1. And similarly, we can also write for four other inverse trigonometrical functions. Fifth point is, if we have sine inverse of minus x, so it can be written as minus of sine inverse x. Then tan inverse of minus x, so it will be equal to minus of tan inverse x. And cosec of minus x, this is equal to minus cosec inverse x. In case of cos inverse of minus x, it will be pi minus cos inverse x. And it is cot inverse of minus x can be written as pi minus cot inverse x. And sec inverse minus x, it can be written as pi minus sec inverse x. So using these properties, we will solve the problem to find the principal values of inverse trigonometrical functions. The first question is sine inverse of 1 by root 2. We know that principal value branch of sine inverse is minus pi by 2 to pi by 2. So we have to find the value in the range from minus pi by 2 to pi by 2. So this value of 1 by root 2 is for sine pi by 4. So we can write it as equal to sine inverse of sine pi by 4, and it will be equal to pi by 4. And this value lie in the principal value branch, so answer is pi by 4. Second question is to find the principal value of cot inverse minus 1 by root 3. We will use the formula that cot inverse of minus x is equal to pi minus cot inverse of x. So it can be written as pi minus of cot inverse 1 by root 3. And we know that value of 1 by root 3 in terms of cot is for cot 60, that is cot pi by 3. So it can be written as pi minus cot inverse of cot pi by 3. And using the formula that cot inverse of cot x, it will be equal to x. So it will be pi minus pi by 3. In simplifying, we will have 2 pi by 3. This is the principal value of the cot inverse minus 1 by root 3. Third question is to find the principal value of sine inverse of sine 3 pi by 5. We have to use the formula that sine inverse of sine x is equal to x. So applying this formula, we have the value 3 pi by 5. But this 3 pi by 5 does not belong to the principal value branch for sine inverse x. This is minus pi by 2 to pi by 2, because the value of 3 pi by 5 is 3 by 5 into 180 degree, and it comes around 108 degree, and this is more than 90 degree. Therefore, we have to manipulate the given expression. It is sine inverse of sine 3 pi by 5. We can also write it as sine inverse of sine, and here it is pi minus 2 pi by 5. This pi minus 2 pi by 5 has the same value 3 pi by 5, so there is no difference. And we can use here the formula that sine of pi minus theta is sine theta. So it is equal to sine inverse of sine 2 pi by 5. And now we can apply the formula sine inverse of sine x equal to x. It will be 2 pi by 5. And now this 2 pi by 5 is equal to 72 degree, which belongs to the principal value branch minus pi by 2 to pi by 2. Hence principal value is 2 pi by 5. This is the answer. Fourth question is to find the principal value of tan inverse sine minus pi by 2. Here we will use the formula that sine of minus x is equal to minus of sine x. In fourth quadrant, sine is minus, So we can write it is tan inverse of minus of sine pi by 2. Sine pi by 2 has the value 1, so can be written as tan inverse of minus 1. And formula is that tan inverse of minus x is equal to minus of tan inverse x. So can be written as minus of tan inverse 1. And tan inverse 1 has the value of tan inverse. 1 is for tan pi by 4. So we can write using the formula that tan inverse of tan x is equal to x. We will have minus pi by 4. This is the principal value of the given expression. Fifth question is to find the principal value of sine of cot inverse of cos of tan inverse 1. Here, this 1 in terms of tan can be written as tan of pi by 4. So we can write that it is sine of cot inverse of cos tan inverse tan pi by 4. This tan inverse tan pi by 4 using the formula of tan inverse of tan x equal to x, we can write it is pi by 4. So expression will be sine of cot inverse cos and then pi by 4. This will be equal to, this cos pi by 4 has the value 1 by root 2. So we will have it is sine of cot inverse 1 by root 2. Now we have to find the value of this expression of cot inverse 1 by 2 in terms of sine inverse. Therefore, we can write that cot inverse 1 by root 2 equal to theta, or cot theta is equal to 1 by root 2. We may mark a right angle triangle. Suppose this angle is theta, and this cot theta is base oblique perpendicular. Here base is 1, perpendicular is root 2. So this hypotenuse will be equal to the square root of the sum of squares of the two sides. So it is root 2 square plus 1 square, that means is root 2 plus 1, that is equal to root 3. So hypotenuse is root 3. So we can write that sine theta, which is perpendicular oblique hypotenuse, perpendicular is root 2, hypotenuse is root 3. Therefore theta will be equal to sine inverse to root 2 by root 3. So this cot inverse 1 by root 2 in terms of sine inverse can be written as sine of sine inverse root 2 by root 3. And using the formula that sine of sine inverse x is equal to x, so we will have it is root 2 by root 3 or root 2 by 3. This is the answer.